So what is 6G? Well, if 6G should be a great symphony, then the technology components is the orchestra, and they all need to work together very well. And in order to build a bridge to why we need test beds and why we need to agree as an ecosystem and as an industry that there should be collaboration between these companies to execute that, is one of these highlights would be, like, we want to use artificial intelligence and machine learning a lot, right? It's one of the big buzzwords. It takes center stage here. And as you can see, I put here 10 technology components. So this morning in the international keynote, we saw 6, so I win by numbers, yeah? But I think it's just based on how you group them and where the interest is, and if you get a little bit more details. But AI and ML can play an important role in all of these different aspects. You find scientific papers about that. Researchers are out there advancing the use of that technology. But literally, we all talk about the AI native air interface, a physical layer that should use this technology. So here's a prominent example that you can find in the internet from Nokia Bell Labs, right? Talking about the neural receiver, replacing blocks in the signal processing chain, like channel estimation, equalization, and demapping with a neural receiver, and then winning about 3 dB, yeah, so double capacity. I mean, that's all based on synthetic data right now, and everybody's interested and hungry to do that with more realistic data and prove this concept. The next stage would be using an autoencoder, yeah, to learn the communication link from an end-to-end perspective. And based on that, this is trained today on 3GPP fading profiles. We have a baseline for comparison. You can see a constellation diagram like that. So now you can still say, why the heck is he talking about that, and what has that to do with test beds? So right now, we have all well-defined KPIs, throughput, yeah? And from an RF perspective, we look at error vector magnitude to quantify the performance of a transmitter, yeah? Which is, of course, impacted by phase noise and all these nonlinearities that's being induced. And we have a very well-defined method with the error vector magnitude to assess the quality, yeah? And that's basically dear to our heart from a test and measurement point of view. So this is very well defined, based on defined signals by 3GPP, defined methodology, how much of the signal you need to capture, where you do your channel estimation, what the signal configuration looks like, and so forth. So if you just think that ultimately 6G might be looking something like that, then the question should be allowed how we measure EVM and how we linearize that. Because you don't know, because we have so many players, infrastructure, chipset, modem, OEMs, everybody comes up with a different model, yeah, trained model, based on a different architecture. So does it all look the same for the same conditions? How we quantify that, how we estimate performance.